good morning, students. Hi, good morning, 3P7. Good morning, everyone who's watching my class today. Okay, so very good morning to you. Okay, I hope that you can hear me. Can you please give feedback in the channel, in the comment section, whether you're able to hear me? Am I coming across loud and clear to you? Okay, Shu Hui, good morning. Hui En, good morning. Okay, everyone, good morning. Can you hear me, girls? Please feedback that you can hear me before I start lesson. Okay. Corsi, good morning. Stella, Crystal, Vivian, Eileen, Ziying, good morning, everyone. Wen Xiu, yes, okay, you can hear me. All right, very good. Xin Yi, Carrie. Okay, so you can hear me, Kai Chi, everyone. Okay, right. Okay, so today is going to be a short lesson, because last week I did mention a little bit about it in your class. So today, because I want to have it recorded, so it's for this week's lesson actually. So last week I mentioned a little bit because there is extra time. So today I want to record it because, okay, we mentioned this during our Google Meet. See, it was not recorded. So now I want to record it for the benefit of other students. Okay, so today's lesson is quite simple concept actually. We've already talked about some safety components in our wiring system. Okay, let's look at the safety components. Before that, let's recall back. In your previous lesson, we talked about how the wiring system was installed in our house. Okay, the components. We have the fuse box. Okay, you also learn about, you see, I've already mentioned to you, the fuse is actually to prevent excessive current from entering wires, because the fuse has a wire which has a low melting point. That means it's easily able to, it can melt easily due to the heat. So why do you have heat? When there's excessive current, all right, the current when it's excessively high will be converted into heat. So it's going to be hot. When the wire is hot, so of course you will have sometimes short circuit, wire will be hot, and then you get fires. And also this heat will also melt the fuse, so it helps to protect your this fuse helps to protect your electrical appliances. Okay, so let me check if anything here. Nothing so much. Okay, nothing so far. So you have fuse box here. You have the electric meter. It's not a safety device. Electric meter is just to read your what's the amount of electricity that you use for this month. Okay, so that you can pay accordingly. The main switch is a safety device. Okay, ELCB. It's called earth leakage circuit breaker, miniature circuit breaker, MCB. All these are safety devices, including your earth wire. Okay, so today we put all the things that we have learned into one topic under safety components. So here, what you can see here, all these things here are safety components that you use in your house. Okay, there's installed in your system, in your wiring system. Okay, first of all, it's a switch, right? Now, what is the importance of a switch? What's the function of the switch first? So as you know, switcher, you can have it on or off. All right, either you can push it up or you can push it down to activate the on and off. The function of the switch is to actually control the current which comes into your house. So if you want to repair anything in your house, the first thing you need to do is to switch off the main switch. So there's no current that enters your house. So whatever you do, whatever repairs you've done, even you touch the live wire, right, you don't get electrocuted. Again, live wire is the one that is very important because it carries live current from the power source to your house. That is the one that carries electricity. So if you touch it when it's on, right, you will get electrocuted. Okay, so this is on and off. It's a switch to control the current which enters into your house or into your devices. Okay, next one. Now you have fuse. Okay, we have seen fuse. Now fuse, there are many types. This is the fuse that you see here. This is called cartridge fuse. This cartridge fuse is disposable. That means after you use it, this is let's say this fuse here, inside it looks like a pill or a tablet. Actually, inside there's a very fine wire. Okay, so after I show you the picture, inside this fuse is a very fine wire which can melt easily. So once it melted already, okay, because you've blown the fuse. Then what you say, you blown the fuse. That means the wire already melted. You throw away. You don't use it anymore. You dispose the whole thing. You buy a new one and you plug inside here. Put it inside here. Okay. So this is usually put. This place for this fuse is actually just next to the live wire. See this live wire? All right, that's why you can't see very well because it's colored brown. So I put red here. This is the live wire. If you're not sure which is the live wire, you always see this is the nearest to your fuse. That is a live wire, because the live wire is the one that carries electricity into your house and into your electrical devices. So you have to have a protection there. If it's too much current, the fuse will have to break off the current. Okay, now fuses have many different ratings. We call it fuse rating. So each fuse is able to allow certain amount of current to pass through. So there's some for 3 ampere, 5 ampere, 10 ampere, 13, or even 15, even 40, 20, 40, and so on. So this shows, the number here shows that if I have a fuse that is labeled 3A, let's say this one, labeled 3A, what does it mean? It means that this fuse is able to allow the electricity to come into to pass through, okay, if the current is 3 ampere and less. Okay, if the current is more than 3 amperes, more than the number stated there, what happens is this wire, the fuse wire, will melt. That means it does not allow current higher than the number to pass through the device. Okay, so because you do not want too much current to pass through. Once it's too much current pass through, this automatically will melt. So this is the number, this is the maximum value. The maximum value of the current which is allowed to pass through. Okay, now next one is ELCB. Earth leakage circuit breaker. This is basically, it's just another fuse, but it's a fuse that you can reset. Okay, but for this, the cartridge which you cannot reset. Once it's already broken, not broken, already melted, you throw it away. You don't reset it. You buy a new one. But this ELCB, all right, you can reset. So there's an on-off switch here. Okay. Either, I'm not sure which one on or off lah, but as long as one is on and off. So and there it is always on, right? Always on. So if in case your lightning strikes your house, then suddenly, I'm sure you've experienced before, suddenly the whole house becomes there's a power outage, right? Everything becomes black, right? No electricity, and then you can hear a sound, suddenly a crack sound that, right? So actually, it shows that this switch has been what we call switched off. So it's automatically switched off because at that moment, some excessive current suddenly went into your wire. And this one can sense when the current is too high, it will just off by itself. Okay, then afterwards, you can just switch it up, switch it again, switch it on again, and then your current will flow into your house. Okay, now, so AMCB, this is a miniature circuit breaker, it also works the same as ELCB. Only thing is it controls a small part of your component in your house. So it is like you have only one ELCB, but you have many LMCB. Okay, ELCB is only one, this is the main one, and then each one of these one is an MCB. Okay, each one of these will control to one part of your house. Let's say the kitchen and so on. Okay, this is the kitchen. This one goes to your bedroom. This one goes to your master living room, master bedroom, and so on. So that is your MCB. Same function as your ELCB. It will it will actually break the circuit. So the keyword to use here is break the circuit, because you see the word circuit breaker. The function is to break the circuit. Okay, break the circuit when current becomes too high, or we call excessive current passes through. Okay, so you have another one, earth wire. This is another safety component you have. Usually it extra wire. Also inside your wire there will have three. Okay, one is live wire, one is neutral, another one is the earth wire. So the earth wire is backup just in case there is extra current that happens to find its way into your wire. That means your fuse not able to melt. Let's say something happened, the fuse doesn't melt, right? But there is extra current, or there's too high current moving inside your wire. If you don't have a wire, what happens is if you happen to be touching the electrical device, this excessive current will pass into your hand, right? It will pass into your body and you will get electrical shock. So when you have earth wire, this is another another choice for the electricity to go through. So if you have a hand, which is a lot of water inside, right? Our body has water, and you have earth wire, two choices. The electricity will prefer to go into the wire, because it's easier to conduct through the wire. You always find an easier way to pass through. For electricity, is we can consider very lazy, all right? You find, if you give two choices, you prefer to have the choice which is easier for electricity to pass through, which is wire. Or wire is always more conducive compared to the body, because body we have water inside. So if you have a wire, this excessive current or the leakage, extra current will not pass into your body. It goes into the earth wire and is connected to the ground. Okay, you can see here, this is your earth wire. Okay, this is going to the ground. The symbol is like this. This one shows that the current goes into the ground. And actually, where you see your earth wire, you can see this is the porch where you park your car and all that. Now you see this is earthing wire. This one inside somewhere. I don't know. I can see in my garden. I mean in my yard there, in the garden or in the yard. So there is the earth wire there. There's a terminal there. Okay. So let's go back to this one. Yeah. Now lightning conductor is another one. Lightning conductor, you see many buildings. You will always have something like an antenna, right, or something that is sharp, and it's always metal. So why we put it on top of the building? There is a function. Oh, I'm sorry. You can't see me. Oh, I'm so sorry. When was it? Okay, so sorry. All right. Okay, let me go through this again. Okay. Have I been explaining, but you have not been seeing? So sorry, girls. Now here. All right. Now here are the pictures that I've mentioned just now. Okay, so this is the earth wire. This is the earthing. Let me show you this earthing here. Okay, when was that that you have not seen the December? Oh, there's quite a few minutes already. I'm so sorry. Thanks for the feedback. Now, it's lagging, right? Lagging. Okay. Just let me know if it's lagging. Very lag. 37. That was some minutes ago. Okay, let's continue first. Right. If any questions, you go to our Google Meet. You can ask questions there. Right. I will repeat over there. Okay, let's look at this one. Where are we? Sorry, wiring system. Yes. So this is a lightning conductor. Lightning conductor, the function is to conduct excessive current into the earth. So let's say when there's a thunderstorm, right? Thunderstorm or very lagging. Can you hear me? If it's very lagging, can you hear me? Is my voice clear? Maybe I switch my Wi-Fi. I'll switch the Wi-Fi to my another Wi-Fi. Let me check. Sorry, give me a minute. Okay, just look at this. Just give me a minute. I'll switch to my data. Switch to my data and hopefully it's better. All right. Okay, let me check. Are you okay? Can you hear me? Comment in the box there. Okay, girls, am I here? Can you hear me? Can you hear me, girls? Okay, let me continue. Very lagging. Okay, So sorry, I think my line is not very good. Just totally white screen. Yes, just now I switched my line. I switched it. That's why there was 1 more minute that it went off. Now it's on again. I hope it's okay now. Okay, let me just finish the lesson. Okay, afterwards you can go through the lesson. Any questions you can ask me. Okay, this is lightning. Lightning strikes your house. But in order to prevent the lightning from striking, we do not want the lightning, the excessive current to move into your wire. So what happens is this lightning conductor is connected to the ground. There's one wire that goes to the ground. And this process is called earthing. When you conduct the additional electricity to the ground, we considered as earthing. Earthing, or we call it grounding. Okay, earthing or grounding. Okay, so what happens if your lightning strikes your lightning conductor, okay, like this. It will strike the pointed end, this part. Usually, the higher the building, the higher the risk of getting struck by lightning. So when you have a tall building, this is a tall building, and a shorter building, let's say this is your house, it has a higher chance of striking a tall building. Okay, and also you do not want the building, electricity, the current the high voltage to shock, to destroy your electrical appliances. So we want to have this current to flow into the ground. So the function of the what they call the lightning conductor, is to conduct the excessive current to the earth. So it brings all the way to the ground. Okay, and it will not damage your electrical devices. Okay, those is it okay now? Students, is it okay? Can you hear me? Is it still lagging or not? Okay, one last part here. Let's talk about the fuses. There are two types of fuses. What you see here is a cartridge fuse, which is made of glass or porcelain. Okay, let me look at it. Okay, yes. So far, okay. Thanks, Chajan. So a fuse function is to melt when current flowing through it exceeds. Exceeds means more than the current or the value of the fuse. So you see here 5A. Every fuse has a number. This number is called the fuse rating. This shows that maximum 5 ampere only can pass through. Any current more than 5 ampere, it will not be allowed to pass through. Okay, thanks. Now it's better. So fuse rating shows the maximum amount of current that is allowed to pass through. So let's say lightning strikes. Okay, this one originally 5 ampere. Okay, no problem, it can pass through. But let's say lightning strikes, suddenly the wire becomes high current. All right, the current increases to 7 ampere. So when that happens, this fuse will melt. Okay, this one will become broken. So the electricity will not pass through. Okay, so that's why it's protected. Whatever is inside there, it will not be burned, it will not be damaged. Okay, so that is the function of the fuse. And you have two types. This is the normal one, cartridge fuse, which you throw away after it's been used. Okay, you don't replace by repairing it. No need to repair. Okay, I think I'm not sharing screen. My sharing screen. Sorry, I didn't share screen. Okay. Okay, now I'm not sharing screen now. So sorry, just let me know. Continue lagging. Okay. So sorry. Now, so this one, where are we now? Yes. Two types of cartridge, two types of fuses. One is a cartridge fuse, which you throw away after it's blown. You call it blow the fuse, is melted already, the wire. Another one is replaceable wire fuse. This one you can replace the wire. You go to a shop and then you can replace the fuse that is already broken. So this block, right, this one is put into the fuse box. So this one is the fuse box in your living room there. Okay, there's a box there, which is we call it the consumer unit. There, this one. Let me go back to this picture. All right, here. Where is the consumer unit? Here, this one. Here. Okay, so you will have a fuse box. Okay, this is called a fuse box. But now we use the MCB lah. Most of it we use MCB, which is can be reset. If you use this one cannot reset. The wire once is already broken or melted already, you have to put another one. So this one is not replaceable. Okay, so this one is not replaceable. This is fuse wire. Usually when you want to replace, you always use back a fuse wire. You don't use a normal copper wire. The reason here is because when you have a fuse wire, it can easily melt. So able to melt. Okay, able to melt is good. Okay, able to melt is a good thing. Because when you want to melt it, that means when a high current passes through, it's able to melt, so it's not current passing through. But normal wire, it cannot melt. Okay, it does not melt. If it does not melt, it's not a good thing because it will not give you any protection. That means high voltage or high current can also pass through. So it will destroy your electrical appliances in the house. Okay, so that is called the wire. That's why when you use fuse wire, you always must replace the fuse with a fuse wire. Don't go and get a normal wire to replace it. Okay. Oh yeah, I didn't share my screen. I'm so sorry. Okay, now I just realized that okay, I'm sharing my screen already. Yeah. Okay. All right. Now okay, right? Now should be all right. Yes, I'm looking at it. Okay. So now next. Okay. So how to determine the value of a fuse? So the value of a fuse is the maximum value that's allowed to pass through, just like I mentioned. So the ratings is fixed one. Whether it's 1 ampere, 2 ampere, 3, 5, 10, 13, 15, or 30. It's already fixed. So you must choose the correct ampere, we call correct fuse rating to put back into your socket, into your plug. Okay, for example, if your electrical kettle, uses maximum current of 11.34 ampere, that means the amount of current that is needed to use your kettle to boil the water, it needs 11.34 ampere. What you should put is your fuse must be a little bit higher. So you do not put something lower than 11. You can put something higher than 11, but it's just a little bit higher, okay, not too high. So you can have a choice of what? 11 is between 10 and 13. You don't have a 11 ampere. You don't have a 12 ampere. Sometimes you may have, depends on that. I think here, according to the list here, you have 10 ampere, you have 15 and 13 ampere. So which is the correct ampere to use? So you always look at the higher one. Okay, take the value that's slightly higher. That will be the correct fuse rating for your electrical appliance. Okay, so you always look for a value which is slightly higher, then that is the correct rating. Okay, so later on, another lesson, we were going to find out how to calculate this value, how to calculate the current of the electrical device. Okay, so now lastly, so here is the functioning of a earth wire. So earth wire, again, is actually to flow the current to the earth, the excessive current. We call it large current or we call excessive current. Usually happens when you have a short circuit, or usually happens when you have a lightning strike. We call it a strike to your house. Okay, so this one, when you're touching it, right, if your hand is holding it, the danger is if you do not have your earth wire, the electrical current, all right, will pass. This is the live wire. Live wire is the brown one. Okay, so the current passes through here and it will touch your hand. Your hand is touching it, so it passes into your body and you get electrical shock. But if there is earth wire, this current will go here, will go into the earth wire. The extra current will not go into your hand. It goes to the earth wire, and this earth wire goes where? This current will go back to the earth wire and it goes into the ground. This is grounding. Okay, so this current does not enter your hand, does not enter your body, but it goes back into this wire and it goes to the ground. Okay, this is grounding. So this is the safety devices. So remember all the 6 types, safety devices. Here you have switch, the different types of fuses, ELCB, MCB, earth wire, and also lightning conductor. So these are the safety devices. All right, okay. So this is for today's lesson. Let's do some questions afterwards in your workbook. Okay, and then after that, we have your time, we'll go through the calculation. Okay, if not, then we'll have it for the next lesson. Okay, so I will stop sharing. I will stop this lesson here first. We go to Google Meet. Okay, thank you, students. Thank you for watching. All right, I'll see you in the next lesson. Okay, bye bye.